Yeah, while we wait, let's just do a bit of, I'd like to know about you. How many of you, by show of hands, are students? Okay, yeah. We are always students in life, actually, but actual students, yes. How many of you have worked with C++? Okay, perfect. How many of you, okay, this is a complicated question, but how many of you know blockchain? Know or have worked with blockchain? How many of you are investors in blockchain? Interesting, okay, okay. Um, how many of you have been in workshops here in, is this your first time actually? Yeah? Yeah, me too. I'm also first time presenter, so bear with me at some points, but I think we will manage. Good, perfect. Okay, so this is what I'm gonna show you, integrating smart contracts with C++. Okay, so first off, just getting to know a bit more about you again. Um, how many of you, and just answer honestly, think cryptocurrency and digital currencies are kind of scammy? Uh, it, how many of you feel like there is something that you don't understand and therefore you are not investing? Yes. Okay, perfect. Of course, of course. Still people are coming in. Yeah. Um, yeah. How many of you? Okay, we are all convinced in blockchain. Yeah. Then let's just do a small exercise here. Yeah. Yeah. Okay. Technical difficulties. But by the end of this presentation, I would like you to know what blockchains are, how they are working, not completely, because there's a lot of mathematics that even myself don't understand, but what is going on, what is a blockchain, how are you interacting with the blockchain, what happens when you make a transaction, how can you make a transaction programmatically, because you could just interact with it just on a case-to-case basis, but we want to make a program that just interacts with something that is off the chain and that pushes to the chain. This is our use case, and this is what I'll try to show you. It's a bit hands-on, so there is a part where I would like you to program something. If you didn't bring a computer, it's okay, you can just join. I will also try to program here, and you can see, so it should be fine. Okay, but then let's start. Perfect. Okay. Here is our summary. We'll start with a small introduction, TradFi versus DeFi, quick concepts, hands-on part, and then conclusions. First part, here's the problem. Okay. Do we know what the Raspberry Pi is? Yeah, perfect. Okay, Raspberry Pi is just a small microelectronics that you can use to make your do-it-yourself project at home. This is our scenario. I am a Raspberry manufacturer. I have a manufacturing order of 20,000 Raspberries, and this will cost me 100,000 to produce. And I don't have that money. But after I sell this product, I will get back 150,000. So I don't have the money to make this fulfillment order, but I do have an invoice from the person that is paying me, and this invoice so how do I get this money? So we're gonna try to compare these two things, this TradFi and DeFi. Trad stands for traditional finance, and DeFi is decentralized finance. So when you hear the word or the words digital currency, you can kind of replace it by DeFi, decentralized finance, and it's the same. So here's the comparison. So okay, I need an investment of $100,000. I just go to a bank, right? I go to the bank, I have my invoice, and I say, okay, I need to fulfill this order. It's 100,000. Can you lend me 100,000? And the bank will tell you, okay, in order to do that, we need to discuss what is the rate, how much will we get in return. I need to know you. So what are you doing? How much money do you make annually? Because that kind of goes to the stress factor. I cannot lend you money that you cannot pay me back. I need to know how much money will you pay me back on a year-to-year basis. I need to know you. And sometimes the client has private or has reasons why he wouldn't like to share this information. Maybe, yeah, still. Maybe this information is private. He doesn't want to share his clients. Maybe the information for his history is not very clear. Maybe he doesn't do the books. Maybe it's a new company that hasn't proved itself. So traditional finance has a lot of limitations for different use cases. For the majority of people, it would work. Let's say you're buying your house. Let's say you're buying a car. You need a loan. You can go to the bank. You can explain. They will look at your finances. So what is how much money are you making? What is, it kind of gets your history and it will pay you based on that. So it's easy to use. It's familiar. We know how it works. It's secure. And here security just means that if you run into trouble, let's say you just made you make a transaction by mistake to an account that you didn't want to make. You can go to the bank and explain, okay, I made this wrong transaction. Can you give me my money back? So there's a support layer that is inbuilt on the system that allows you to just get back your money. So these are all of the advantages that traditional finance provides. And then there is decentralized finance. And when we're talking about decentralized finance, we are talking about crypto, digital currencies. And please correct me if I'm wrong or if I say something incorrect, but my understanding is that crypto started when we hit this big world crisis in traditional banking, where there was a lot of speculation and derivatives, and the system was built in a way that people were exploiting it without consequence, and there were a lot of middlemen that were handling your money that would take a cut, and this just made for a system that was very inefficient. This just made so that you weren't really in charge. Let's say, for example, here's a scenario: you are working. So you are a political, you are part of a political opposition in a country. This country, if it has centralized bank, then it could go to your bank and say, okay, this is someone that we don't like. Can you freeze his accounts? And they have this power. So in traditional banking, since everything is centralized, your money is, there's an exploit where you could lose access to your money. And so decentralized finance just appears in a way, just provides a way to bypass all of these problems. So first great advantage is censorship resistance. So even if you are a political opposition, you can't really be prevented from participating in this exchange. There's also faster transactions, cheaper transactions. I don't know what your experience is with banking, but if you have an account, sometimes you need to pay something and the bank will just tell you, okay, we can only process this transaction tomorrow by 3 p.m. But why? Is the database failing? What is wrong? No, it's just, this is our working hours and we don't process it out of working hours. And these artificial constraints are just weird and unnecessary, and decentralized banking just providing a way to go away from this. And since there is no middleman, there is no centralized database, it also just takes away this money that you will be giving to people that are managing your money, because now the blockchain kind of manages itself. I'll go into more detail there, but the key takeaway here is that traditional finance has a lot of problems. It works for the majority of people. If you're dealing with mainstream cases and you need a loan for your house, for your car, you're an investor and you need some money to fulfill an order, it works for you, but you have to kind of have a history. You have to you have to make yourself known to the banker. And decentralized finance doesn't really have these constraints. It's trustless by default, so it just means that I don't need to trust you to give you money. It sounds weird, but the way that it works is just programmatically and mathematically. You are ensured that your money is yours to spend, and that when you enter into an agreement with me, for example, we'll talk a bit about smart contracts, but if we both enter into an agreement, there is no way that I will give you money, so I'm paying for a service. It's not like I can just pay you money and you don't give me the service back. That cannot happen because it's inbuilt into this blockchain kind of infrastructure. Okay, so far, any questions? No? Perfect. Maybe some of this is a bit beginnerish. If you feel like it, then just bear with me for a bit, because I don't know, your backgrounds are very varied, so I'm trying to just bring you up to speed to the same level, and then we'll just start to pick it up and make it more complex. But okay, traditional finance, decentralized finance. And now I will show you some key concepts. Okay, so I was expecting to have just something to write on. Maybe I'll just try some paint. Let me know if you can see it. Probably, yeah. I will try to make it work here, but okay. So here are the concepts that you need to understand in order to trust blockchain. So blockchain. So if you know a bank, how is a bank working? If you have an account in a bank, then you just have some money, and then when you make a transaction, you just spend some money, your money goes somewhere else. It's a closed system, so money that you lose just goes to someone else, and the money, just transactions are the bottom line of managing your bank account. So you have money, money goes in, money goes out, and that's all there is. At the end of the day, just a bank, you can think of it as a list of transactions. So your current balance is initial balance, take away and put what got in and what got out. And what the people from blockchain understood is that actually we can make this banking, we can make something that is similar to a bank digitally. So a blockchain, first of all, is just a chain of blocks, right? So a chain of blocks, a block, you can think of it as, here's a block, and a chain is just linking to another block. Okay, and what is inside the blocks? Inside the blocks, we just have transactions. So transaction 1, transaction 2, and you can look at these transactions as operations in this thing that we call the chain. So at every time, okay, let's look at the Ethereum virtual machine. So the talk is going to focus on Ethereum mainly. Okay, one second. I think I have the presentation that I'm presenting is the old one. One second. Yeah. Oh, sorry about that. Yeah. Okay. Yeah. About that. Yes. Okay. So a blockchain is a chain of blocks. Blocks contain transactions, and transactions are just encoding uh, the transfer um of value between one account and the other. So every transaction is made up of two. Where is it going to? Where is it from? A gas price, kind of, and a payload. And all that is happening on the chain is just there are some nodes. You can think of nodes as just a distributed computer. Around the world, there's just computers running code and updating this big state that is the blockchain. And every second or every cycle, the nodes we can look at the nodes. Every cycle, the nodes just go to the blockchain, look at triggers, events, new events, and then just process this information. I would like to show you just some documentation. I'll make this available to you. I don't know if there is a platform we can use, maybe Slack or yeah, Slack would be the way to distribute it. But so there are nodes in the network that are processing new events. New events will trigger different events. The way that the events are processed is implemented in smart contracts. You can think of a smart contract as just something like a vending machine. I think that is the best description that I've heard so far. So a smart contract is just a piece of code that is deployed inside the chain, and whenever a trigger happens um, that is recognized by this smart contract, it just triggers something else. It will run some logic, and then it will trigger some other event. And the logic that is running just depends on a piece of code that is implemented. That's what a smart contract is. It's just a piece of code that gets implemented and then gets run every time the nodes understand that it needs to be done. So far, so good? Maybe it's, yeah. Okay. And let me just, I would like to show you blockchain tech stack. I don't know why it's not opening. Copy link. Do you have internet here? Yeah? Oh, okay. Bear with me, please. And open. Okay, perfect. Okay, so I'd like to introduce you to something that is called the tech stack. A tech stack is just a way to understand a network. Probably uh, you know about a tech stack, for example, for the Aussie model. So how networks communicate. There's a physical layer that connects to a network layer, and then like when you're making uh, a request from one computer to the other, you're just passing through all of these layers and then coming back. And there's something also for blockchain, which is called the blockchain tech stack. And you can think of a blockchain as just multiple layers on top of each other. So on the first layer, you have the the chain, the actual chain. So let's say we are dealing with Ethereum. On this layer one, you have ETH, which is the blockchain that natively is supported by Ethereum. So you make transactions, you're just dealing with layer one. On a second layer, you would implement nodes, nodes for nodes and communication that will handle these the transactions on layer one. On layer three, so the layers are just cumulative, and you are building capability on top of the previous layer. So when you get to layer three, you just can do things that deal with multiple blockchains, that deal with something outside the chain. So the big problem. Okay, maybe let's go back to these slides. But the big problem that we have and that we are trying to solve in this workshop is when you are dealing with transactions, you can only transact using information from the chain. So if you have, if you need to make a payment, you need to use information from the chain. So I need to, here's a scenario. I need to, here's my use case, okay. Let's just jump in. Here's my use case. So I'm a teenager and I want to stay away from digital currency. It feels kind of scammy to me. And there's a party, a big party, and I want to be in this party. There's an invitation for me, and in order for me to get in this list of attendees, that people that can join the party, I need to pay some money. So if I have a digital wallet, I can just go pay the money. So it's 1,000 Ethereum. If I can just go there and pay, and now my name is on the list, and I can just attend the party. But for some reason or other, I don't feel safe paying through these digital currencies. So I want to pay off-chain. I want to pay the organizer directly in money, in dollars, and I want to be added to the list. So this is a use case that is not natively supported in the blockchain, because if you are paying off-chain, then the Ethereum virtual machine, the network, cannot make transactions based on information that is outside the chain. And this is a very small toy example that we are going to deal with, but the idea here is that you just need to make a way to get this information that the payment has occurred and push it to the chain in order for it to unlock to unlock the information and to add you to the list of members in this party. So this is the problem that we are trying to solve. And kind of the big problem here is that natively you cannot interact with off-chain data. So you just make, you need to make a way, you need to make an application that exists in layer 3, which is equivalent to an oracle. So you just need to make something here that will contact someone, just an external REST API, and it will get information about the payment, and then it will push it to the chain, and then the chain will interact with the smart contract and tell you that the payment has occurred and that you added to the list. So far, so clear? The problem is understood? Okay. Then maybe, yeah, let's start with the hands-on part. Here is our link. Do all of you have computers? maybe let's just get a bit together. All of you have computers, laptops. Yeah, I see some. Yes. Yeah, you need exactly. Yeah, yeah. Underscore two instead of lower two. But what we are gonna do now is just jump into a bit of hands-on, and I would like you to try some of these some of these concepts. I'll explain to you the smart contract structure. And if you don't have a computer, I would advise you to just try to get together. But it should be fine because I'll also be projecting and developing here on the side. Oh, okay. I am using the Ethernet cable. That's good to know. PHC. Okay. Just 1 second. Let me switch. Step one. Yes, that's okay. Let me just make it easy on you. So password is PTC. No, P. I have it somewhere. PHCconf Porto Hub 2023, and the link to this repository is instead of DTH this and 2023. Okay. Can you see? Feels like it's very small. Can you come closer, maybe? Whoever's set up. Otherwise, I'll just try to make it. Because also for programming, it helps to just have a lot of space, just wider. Can come even closer. If you need to see, it helps to be closer here. But this is just a Git repository that I've created for this exercise, and what you have here is just the starting point. You should check out branch step 1, and I can write it down. And what you have there is just a small repository. It's not doing much at the moment. There is a main, so git check out, and the branch is step 1. This is the starting point. It's a small repository. We can go just line by line. If you already work with C++, then it should look very familiar. Oh my gosh. Should look very familiar. But so let's just go through this repository. Okay, just again, for my understanding, how many of you have worked with C++? Okay. How many have worked with Git before? Yeah, perfect. With smart contract, Solidity, are you familiar? Perfect. And front-end development. All right. Yeah, right. Perfect. So in this project, we just had assorted code with various multiple purposes, but let's just go through this. So let me go back here. Here's what the problem was. We have just, we're going to work in Ethereum, but we have this Ethereum network where there is information about the party. So in order for me to join a party, a physical party in the real world, I just need to have my address in a list. The list is part of an Ethereum smart contract, and that smart contract is just deployed on a network, an Ethereum network. So let's kind of think about it like this. And in order, so if I have an account in this Ethereum network, I can just pay, and now I am inside the list. But if I don't have an account, then I just need a way to communicate to someone that a payment was made, that someone will push to the chain this information of payment, and then my name gets added to this list. That's our use case. So let's say that there is here just a platform that I can access where I have payment information. So payment, oof, this is not ideal, I guess. Cool. Yeah. And then what I'm kind of writing, so our implementation, our use case is just an application, so a decentralized application. It's kind of the way that we refer to this, that will contact this payment information platform, and it will push to the chain, and then by pushing to the chain, it just triggers the transactions and the operations that will start, that will inform the list handler that I am now registered. So this is what we want to implement, and that's kind of the code that we have here. So C++, okay. This template is Um, this is kind of a template that resembles the pitchforks template. What you have here is just a test folder. There's nothing there. It's there for historical reasons. What we are planning to implement is going to be here on the source folder. There are some libs, libraries. These are implemented by us if we want. There's already an example library there. There are some external libraries that I've chosen. These are just suggestions. You are free to use other libraries if you feel are better. Docs folder. This is for Doxygen. We're not going to use most of these. This is just the layout of the project. Some tools. The tools are mostly just scripts to handle the project that don't really have to do with functionality. It's more to just start up the project. We have some readmes. This is like how to get this project set up. Feel free to use this template. I use it for myself, but if you'd like, you can just download it and use it. And then this is a markdown file with the problem. And there's also this contracts folder where there is I have implemented a small server that will handle the pushing to the blockchain. But we can go by it afterwards. Okay, maybe let's just start with making this project run. So I've already made the setup, but you probably, if you don't have CMake installed or all of these dependencies, that's the first part. So if you're following along, small README here. At the end, what you need to be able to do is just compile the project and run it. So how do you compile this project? Let me just delete the build folder. Okay. But following along, how many are following? Okay.
I'm trying to, but I'm in the same branch as you at once.
Yeah.
For some reason, I don't have the same file.
Okay, you have less files. Probably don't have the external libraries. There is the first step. We need to set up the projects. Do we already have these things installed? Okay. If you don't have all of those installed, you can just see. It's going to be sudo apt install, and whatever packages are here. So CMake is a tool that manages C++ recipes. So in order to build these files, you could, so just for your edification, if you need to build something in C++, you can do G++ and then the source file main.cpp and then -o and out. This is what you use for compiling a file. But if you want to just manage a complex project, you need something just more easy to use. You cannot just write recipes by hand. You use something called CMake. How many of you have worked with CMake before? Okay, C++. Yeah. Oh, also Conan. Yeah, I think that. Yeah. Which was it? Conan? Yeah. I don't think it's exactly this. Okay, yeah, understood. Because I think there's also like Babel, I'm not sure. I remember there were some alternatives to CMake, but you can think of CMake as just the tool that is supporting building the project. It makes building simpler. And this is the types of files that it uses. I'm not going to go into too much detail on this because it's going to make the presentation so much more complex. But all of the dependencies that you need, so if you need to use a library in C++, you just add this library here to this list, and then you can just include it and implement the functionality that you need. and run the product. Okay, so yes, no, no. That is more of a recommendation, but yeah. Then okay, so for this project, you are gonna need CMake. CMake format we are not going to use. This is used to just, it's a linter for CMake files. CLang format is a linter for C files. Docgen is for documentation. Gcov is for coverage of the of the unit tests, and then Ccache is to cache the build artifact, so it's faster every time that you need to compile. For this project, you just need the CMake. So sudo apt install CMake, and you should be ready to go. Right? If you're following along, this is the command that you need, CMake. And after it, I already have it installed, so you'll probably just tell me, all right. Yeah, it's already installed. Okay, and after you have it installed, you can compile this project by following these steps. So what you need to do, I already have some macros that are implemented here on the tasks JSON file. So if you're using VS Code, and I do recommend that you use it, it's very straightforward to run this product. What you need to do is normally I have a perfect. Normally I have a keyboard, so it's struggling a bit. But this is what you need to do in order to start the CMake. So command by command. This is just creating a folder. So you go to the root of the project and you create a folder. Maybe build is enough. Then you just jump into that folder. So cd build. And then you're gonna run this CMake, the program that we installed, and the debug type. And then the location where you can find the root CMake file. So right here. And you should get something like this. So it has detected all of the packages, and right now it has recognized our compile recipe as, so all of the dependencies are loaded, and right now it hasn't compiled anything, but it just is looking for libraries and seeing if the required libraries are there, and just putting everything into place. It actually generates a make file that then you can use to make your project. Okay.
Are you on the step one, right?
Yeah.
Because can you check if you have uploaded to the remote? Because even on the GitHub, I don't see every file that you see there.
Okay. Okay.
Maybe you need to do a git push.
Okay. You should have. 1 second. Git origin step 1. Yeah, this is already pushed. Okay, let's go problem by problem. Let's start here. Where is?
I'm here.
Yes.
Step one.
Yeah.
And I'm gonna show you the files, so you see you don't have all the files.
On the source file.
And even the external directory.
Yeah, external. Oh, yes, exactly. So external needs to be started. So we are dealing here with some modules. Our C++ project has the following submodules here. You can find them. We are using curl to make calls to REST APIs. We'll use these tools and make to this is just a repository that I use with some macros for CMake, and this external JSON to handle these files. Okay, yeah. First, I need to start the submodules. So there's a script. If you go to scripts, yeah. What command did you use?
Git submodule update --init --recursive.
Yeah, it's recursive, exactly. So this is just a command that will go to that list of submodules and pull the most recent version. You need to run this. If it doesn't work, then you need to, you can also use this script here called init submodules sh. And by the end, I expect you to have these three submodules: catch, curl, JSON. Just let me know if you are having any issues.
I cannot, and now I'm listing this in Longman JSON.
JSON. Okay, so you should have a JSON folder in this external library. Okay, something happened that the submodule didn't get added. Go here.
Git modules.
Yeah.
And it's here.
Yeah, it's here. Why is it not coming? Try to run the script on the tools. So there's a tools, scripts.
Init submodules, right?
Yeah, run this. And by the end, it should have added this.
No, that's weird.
There's an alternative where you just clone the repo into this folder, but it's not ideal. How are we doing? Have you very good one? Okay. CMake error. Tell CMake where to find the compiler. Ah, okay. Did you install the? Do you have the toolchain, the SDK for compiling C++? Build essentials, probably. Ah, okay. We need to install the G++ compiler as well. So if you have a running setup for C++, then you should be able to do something like this: G++ minus v. Oops, minus version. This will tell you that you have a compiler at version 9.4. If you don't have a result here, if it says that the command is not recognized, then you need to install the G++ compiler. You can do that by build essentials, I believe. So install C++ compiler. A lot of the development work is going to Google and finding what your problem is. I think it's build essentials, but I'm just making sure.
Yeah, it's build essentials using the Debian.
Okay, yeah. Exactly.
It's essential, not essentials.
Mm-hmm. So this is what you need. And after you do that, you should have should be able to do a G++ minus minus version. Are we good? Are you what? Okay. Does anyone need help with? No?
I also needed to install libcurl dev. Now it's compiled.
Libcurl dev, okay. Yeah, exactly, because that's the library for curl is running on top of libcurl. Good, working. Okay, perfect. Okay, so after you have updated the submodules, you will see 3 folders: catch, curl, JSON, and if you install the build essentials, you should be able to do plus plus version. This will tell you the compiler version. Compiler version doesn't matter too much. It should be compatible with wherever version you have, but the most recent is always the preferred one. Okay. So if you go to Markdown, the problem, again, these are the steps to solve this task. So the first step is going to be that we request a call to a conversion rate for Ethereum to US dollar. So basically, what are we going to do? We are going to go to this payment platform. We are going to check what was the amount paid. We are going to make a conversion to Ethereum. We are going to check the price of membership on this exclusive club. And then if the price that was paid is above if the payment is above the price, then we say okay, and then we push to the chain, and then the name gets added. Those are the steps. And so kind of breaking it down, what we are going to do is, first step, we make a call to get just conversion rate from Ethereum to US dollar. I have suggested this URL, this endpoint for getting that information, and this is the output format that you're gonna get. Actually, Ethereum to US dollar, I think it's switched around, but let's just make this, let's get that, and you can see, I use this extension for REST API requests. This is like Postman, but it's an extension in VS Code, so it just helps to make this simple. But if I use this website, I can see that, so the meaning of this is that 1 Ethereum right now is worth $1789.88. And if I do it again, change the bit, okay, it's going up, it's going up, it's going down, maybe. So this is just real-time conversion rate from Ethereum to US dollar. This is the first step. This is what we want to do in step 1. Where are we going to implement this? You just jump into the main SRC, and we're going to implement it right here. Okay, my suggestion here is that we use the libcurl library. So curl, what is curl? Have you used curl before? Yeah. So curl is just a library native to, is it native to Linux? No, okay. It's a library that you install in Linux, and it just supports REST API, API external API requests to wherever you need. So if you were to do this in a terminal, you could do something like curl, the place that you want to get. I'm just giving you how you would do this manually, and then we can, because the first step to resolve a problem is just try to do manually what you want to do automatically, what you want to automate. So this is what we need to do. We do a curl to this endpoint. Okay. suggest, then let's just get you to implement it. Just feel free to implement it alongside. What I suggest here is that we use this HTTP client CPP. So in this file, we're just gonna implement uh, a get request function that will give us um, the result for this call. So first step is to read some documentation. Actually, wow, perfect. Do you have what is it? It's an extension for Copilot. I have this extension for Copilot in VS Code, and it's already suggesting me the solution for this. I can accept it. I will just accept it because it makes this demonstration a bit simpler, and then we'll go line by line. But I also want to give you the experience of programming in C++. So let's say you just have a use case. Okay, I want to call this API and get the JSON result in my main program. How do I do this? I have the library. Sometimes I don't even have the library, so I just go to Google and okay, how can I get a REST? How can I do this? What library would I use? You just go to Stack Overflow. You decide on a library. Maybe it's easier. Maybe it's faster. Maybe it has a simple interface. And then as soon as you have the library, what you do, you can go back to Stack Overflow and just, okay, how do I implement this? Or you can just try to read the documentation. And uh, projects vary a lot on how they implement things, but you can like for the most part you can find some tests, and tests are a perfect place to find how to implement your use case, because they are going to have something like a client to make a get request, but sometimes they also have a an examples folder. And yeah, we have a docs and examples. There we go. And you will see the FTP get. Yeah, there's a get info. Is that what I want? Yeah, exactly. So this is how you implement a get request in for the libcurl. Right here, what it's doing is just um, using this URL, and this is where the breaking down the code. Curl, this is just some, think of it as just a pointer to this functionality. You are first setting up the call that you want to perform. So you just define the URL. You can define headers as well. You can define a body for the call, and then you do the actual call. And then you just check if the call was successful, and by the end you should have a result body. Uh, in this case, I think it's just doing a get here and then checking if it got a 200. So this is a simpler use case. What we want is to check if there was a 200, and also to get the body back. And how would we do that? So let me just go back to this implementation. Okay, so it already gave me some code. What is it doing here? Yeah. I also need to implement. Yeah, okay, so right here, what's going on is I'm implementing a method to make a get request, gets two parameters, request URL and a password. We don't need the password for now, but it's going to be useful later. The request goes here, so we are just setting up that. And then we need the write function. So the write function is just a way to get back the body of the result. So if you remember from this request, when I make the request, I get back this. So The right callback is just what I'm gonna use to get it back. Again, how do I implement that? Yeah, exactly. We need that. Give me a second. Oh, one second. Need to mask. Okay. Just finding how this right callback function is implemented. But basically, this is what we need. Okay, and maybe you are asking yourselves, okay, what is going on there? This right callback function is gonna get the result from this request, and it's gonna put it in a string variable, just appending character by character, and at the end it just gets returned here, and that read buffer will be called by that. A second. Exactly. Yeah. Okay. After the init is done. Okay, the code is not complete yet. Maybe I'll add this. I'll just show you the solution. Oof, became so much more. Okay, this is the full solution. So, what is going on here? There is a request URL that is passed as a URL variable to this curl easy set option. You can do this easier, more easily. I've just made this previously, and it's kind of the way that it got arranged. But the first steps are just preparing the request that I'm going to do. So I put some headers there. Then I define the URL as the parameter that I got from this GET request. Then I verbosity, because otherwise I'll just get a lot of information on the terminal. A username if I have it. Write function, this is where I just get the where I get back the information from for this, and then this is the output variable, the buffer. It's a string that I've defined previously, and I will make a easy perform on this curl. So if I now call this get request on my main, I will be able to see. So how do I call that? Response, and it will be get request with that. And then I would like to std cout the response. Okay, let's now compile this code. So compile, I just cd build, make all. Okay, it's giving some warnings because of some dependencies that were included here. And by the end, I should have an executable with the name of the project that I can run. Okay, let's see. If I am in the build folder, yeah, you should have something like this, PTH 2023. And if I run it, 2023, I'll see, okay, this is the value for Ethereum. Oops. The value is kind of fixed. It's not changing much. But, oh, okay, yeah, so this is $1 converted to Ethereum. I can do the opposite, which is 1 Ethereum to $. That is just the platform will, oh yeah, because I'm not compiling. Okay, now that I have the new compilation, I should be able to see the conversion rate from Ethereum to $, which is 1775. Okay, so this was the first step. First step is use this platform to get how much is a $, in Ethereum. Was everyone able to implement this? Yeah. Okay. Yes. All of the code is also on the branches. If you check out step 2, for example, you can see the code. But it's easier if you just check out step 2 and.
But I want to do it myself.
Yeah. Okay. Okay. Of course. Were you able to? Okay. Show me the repo. Probably it's the external folders expand this. Okay, curl is there. Did you install libcurl? Okay, that's it. Sudo apt install. I think if you don't have a computer, maybe you can join here and yeah, so that. You couldn't? Okay. This is a hands-on part, so at some points we're gonna struggle, but we'll be able to push through at the end. Yes. Okay. the instructions you should. Okay, show me. Let's make. Let's. Yeah, you are at the root of the folder of the project.
I cloned the GitHub project to this file.
Okay, okay, exactly. Okay, you are in there. If you do that, that's perfect. Okay, first create a folder for the build. Okay, jump there, cd build. Yeah, perfect. Okay, and now we need to run cmake in order to prepare the make files. So what you do, exactly, cmake. And there is an instruction to make a debug format versus a normal. You don't really need it. Just copy that, -d. So this is what we call, yeah. And instead of double, yeah, space, add that there. And now this, the last argument is just where you can find the root cmake file. So it's just dot dot, not dot dot slash. It would be slash if you were using build slash debug folder. Yeah, run it. Yeah, exactly. Perfect. Okay, it's telling you that it wasn't able to find these libraries. You need to pull the dependencies. So in order to pull dependencies, you run that command git submodule update minus minus init recursive. Submodule update minus minus init dash dash and then space dash dash recursive. And it's submodule. There we go. Okay, now it's pulling all of these submodules. How about you? Were you able to?
I'm trying to make my
Yeah.
compiler work.
This is Windows? No.
Yeah.
Yeah, okay, Windows is a bit tricky. Okay, cloning, perfect.
At first I tried to do on Kali, but I don't know what happened.
It wasn't working? Should be working.
It shadows my bars because I think I did an update.
Mm-hmm.
I googled.
Mm-hmm.
Someone said that when you do update in Kali, sometimes they shadow your bars, so you have to put it again. I don't know. It's the first thing that it happens.
Normally just use vanilla Linux. Do I still need this? Oh, stupid. You should just get closer. Yeah, perfect. Okay, yeah, all the paths are now checked out. Okay, now try to run the cmake again. Cmake minus d blah blah blah. If you hit up arrow, yeah, it just goes to the history. Yeah. Perfect. Let's go. Okay, everything is built, is ready to build. Now, in order to build, you make all, or yeah, all is just so you are saying make, and then the argument is the target that you want to make, and you want to make all the targets. You could also do make pth underscore 2023, and it would also work. And by the end of this, you should have a working. Yeah, yeah, yeah. And then you can implement that. How are we on time? If you remember, the blockchain is made of nodes. Posso falar português? Ok. Temos uma blockchain. A blockchain é feita de nós. Os nós estão a correr smart contracts. E o que eu estava aqui a dizer era. Já me esqueci. O gás, exato, ok. Gás, ok, exato. Imaginem que eu tenho aqui um smart contract que quando ele é trigado, fala com outro smart contract e o segundo smart contract triga outra vez o primeiro smart contract. Vamos ter aqui um infinite loop. O gas é só uma maneira de garantir que não temos transações infinitas. É um custo por transação. Quando nós fazemos uma transação, gastamos um certo gás. E aquilo acaba também por ser uma ferramenta para garantir que não há overflow da rede. Imagina, eu quero fazer uma transação. Se vocês se lembram daquele modelo conceptual, isto é um bloco e o bloco tem transações. E a cada ciclo eu faço um bloco novo e meto transações novas. O número de transações que cabem num bloco está definido. Eu não posso meter infinitas transações, por isso a rede tem de escolher que transações é que vão entrar. Então, quando a rede está muito congestionada, imagina que há muitas transações, nós pagamos um certo custo por adicionar a nossa transação ali. Quanto mais transações tiverem na queue, na fila, mais custoso fica adicionar uma transação. O gas é esse mecanismo, ele garante que nós vamos meter excesso de transações porque aquilo tem de ser processado por computadores. Então é esse o significado daquele parâmetro. E agora se eu voltar ali. Oh my god. Ok, exato. Se eu voltar aqui, eu posso ver que, exato, portanto, ele prepara aqui a transação, quem é que é a origem desta transação, para onde é que está a ir, vai chamar aquele smart contract. Aqui ele prepara mesmo o payload, o tal payload. E o payload o que é? Vai ser este address, que é uma string. Quando falamos de um address, estamos a falar de uma public key de uma wallet. Por isso, se vocês virem, vamos já ver isso melhor, mas há de ser algo do género 0x, em hexadecimal tem 40 caracteres. E eu vou fazer uma assinatura dessa transação. Exato. Portanto, eu assino a transação, depois faço o tal push para a chain. Vamos mostrar uma coisa. Ok. Quando estamos a lidar com blockchains, temos aqui ferramentas. Lembrem-se que a blockchain é uma rede pública, todas as transações são públicas. Se eu souber, por exemplo, o endereço da tua wallet, eu consigo saber para quem é que estás a transferir, quem é que estás a receber. Isso é uma das grandes vantagens, por isso é que nós conseguimos garantir que ninguém pode ser censurado, porque é tudo público. Mas ao mesmo tempo também tira um bocado da privacidade de, sei lá, quando eu faço uma transferência no banco, ninguém sabe quanto é que eu paguei e a quem é que eu paguei. Mas na blockchain isso é um bocado feature da rede. Mas pronto, há aqui uma ferramenta que é o que nós chamamos um block explorer, o etherscan, e o que ele nos deixa fazer é ver transações que estão a acontecer em tempo real na rede. Por exemplo, se eu for à página inicial do etherscan, eu consigo ver Sim.
O endereço que é processado com etherscan supostamente não precisa de uma transação efetuada?
Ok. Portanto, o pagamento é feito off-chain. Alguém paga pela pertença a este clube e depois há um serviço que vai validar que o pagamento ocorreu e depois vai chamar o sabe?
O que aparecia no etherscan era sempre já de pagamentos processados. A minha questão era estar a tudo. Ok. Pronto, sim, pode ter processamento.
Não. Mas é um bocado diferente, ou seja, o etherscan não é para processar pagamentos. O etherscan é só uma ferramenta de visualização de transações na rede.
Sim, mas atenção é que tinham que estar todas registradas, ou seja, que eram todas processadas. Mas vão feitas pode-se colocar lá, ela estar em processamento e depois nunca ser efetuada.
Ah, correto, correto, sim, sim, sim. Isso também acontece. Uhum. Exato. Uhum, sim. Isso tem a ver com a maneira como os blocos funcionam. Como aquilo é uma blockchain, tu tens um bloco, o bloco vai ser enchido com transações. Depois, antigamente tinhas mineiros, tipo, há um processo de um consenso, um algoritmo de consenso, que é a maneira que nós, tipo, o algoritmo para garantir que os novos blocos são adicionados. Isso em Ethereum agora é por stake, tem tais técnicos meio complexos, mas o takeaway aqui é que tu fazes a transação e o bloco tem de ser validado. Enquanto ele não for validado, a transação não é válida, é como se não tivesse acontecido. Só depois de algum tempo é que realmente fica efetiva. Isso faz aqui. Quem tem internet? Done. Ok, já.
Eu também não tenho.
Não? Ok. Posso fazer um hotspot aqui do meu telemóvel. Mas se calhar voltamos aqui. Hum. Mas também para a explicação, acho que não será necessário. Exato, portanto, aqui na transação, ok, o meu servidor de TypeScript, o que ele está a fazer é, ele tem uma porta e tem um endpoint, que neste caso é um endpoint para um post, e ele está lá à espera. Se alguém falar com ele vai receber a informação do body deste pedido e vai tirar o endereço da pessoa que eu quero adicionar à lista e a quantidade que essa pessoa pagou. E depois com essas duas informações ele vai e faz um push para a chain. É isso que está aqui implementado nesta funcionalidade. Portanto, eu quero vos mostrar.
Ele aí faz um push daqueles códigos que devem ser mais crescentes, é isso?
Vai fazer um push do resultado desse código processado e convertido em transação.
Mas o código é compilado antes, ou seja, tu compilas na tua máquina ou tu mandas o código ser mais crescente? Ou...
Não, eu não estou a compilar o código, eu estou a compilar mesmo o resultado do código.
Ok.
Temos internet. Parece-me que estava a falhar. Já voltou. Okay. Ok. Então, pronto, como eu vos estava a dizer, nós temos todas as transações são públicas dentro do Ethereum e aqui vocês conseguem ver, por exemplo, as últimas transações. Por exemplo, eu consigo ver que esta transação aqui, esta pessoa, onde é que está? O from, portanto, esta wallet enviou para aquela wallet o valor de 2.000 euros. Isto é o pagamento, 2.000 euros não, de $0 aparentemente. Mas isto, porque a conversão é muito baixa, estamos a falar de 0,000 ETH, que é quase nada. Mas é tudo público e neste caso é um pagamento de alguma coisa. Podemos ver mais detalhes, por exemplo, como é que isto é processado. Mas isto é um pagamento, é simples. Quando estamos a falar de um smart contract, nós estamos a falar de uma chamada de uma API do smart contract. E isso é feito de maneira diferente. Por exemplo, vou-vos mostrar como é que seria a chamada do nosso smart contract. Ok, pronto. Este é o nosso smart contract, está deployed neste endereço. Imaginem que eu quero ver o preço de admissão para a tal festa. O que eu faria é chamar o método que é o get membership price. Certo? Portanto, get membership price, esta entrada aqui. E o que eu vou fazer é uma chamada para este método. Ou seja, eu vou falar diretamente com a blockchain. A blockchain tem RPC, tem comunicação por RPC que eu posso fazer. E como isto é um read-only, eu não vou alterar a chain em si, eu só vou fazer o query do valor, eu consigo usar o RPC. Por isso, eu quero fazer esta chamada. Get membership price para obter o preço. Ok. Então, como é que eu faço esta chamada? Eu basicamente vou fazer um get request para esse aqui, pode ser. Ok, portanto, este aqui é um dos endpoints que eu posso usar para comunicar com a blockchain. O formato da comunicação é este aqui. Portanto, os parâmetros estão aqui com quem é que eu quero falar. Aqui eu vou meter o endereço do contrato. Neste caso é este aqui. Então. A seguir, aliás, não. O from é quem é que é o originário, ok? O to é o contrato. Okay. A data da chamada, isto é um payload. O payload, pronto, aqui é que entra a parte do ABI. Digamos que eu quero falar com aquele método específico no contrato. Eu não venho aqui dizer o nome do método, não é como se eu pudesse chamar get payment or price, blá blá blá. Na verdade, nós usamos uma coisa que é um ABI encoding. E esse ABI encoding, há ferramentas para calcular. Eu vou-vos mostrar aqui uma ferramenta. Neste caso é free, é online, que é este ABI Hacks.org. Portanto, se eu vier aqui, podemos ver o que acontece. Portanto, se eu quero chamar um método, como é que chama o método? O método é este, get membership price. E agora, eu quero ver como é que aquilo fica convertido em ABI. E ele tem argumentos? Será que tem? Não tem argumentos, ok, excelente. Vai-me tornar um int. Portanto, o que eu preciso fazer é enviar esta data aqui. Este é o payload, ou seja, o meu método dentro do smart contract é identificado por esta string. Vamos só fazer a corrida e ver isto a funcionar. Ele vai-me dizer o preço de pertencer, portanto, se eu quiser ser adicionado à lista de pessoas que estão nesta festa, eu tenho que pagar este valor. E isto aqui também em si tem de ser desencriptado, mas isto é um int, é um inteiro. E tem muitos leading zeros, mas o valor em si é este aqui, 3.000, ora 3 já, blá blá blá. Está em hexadecimal, deixa eu converter, calculadora. Eu consigo ver que equivale a 15.000 Whey. Não sei se vocês conseguem ver, mas são 15.000 Whey. E o Whey é uma unidade que corresponde a uma fração do if. Porque quando estamos a lidar com Ethereum e com moedas digitais, faz sentido ter uma unidade mais pequena do que o próprio Ether. Por exemplo, um Ether vale 15 mil dólares e vale 10 levantado a 12 Whey. Certo? Se quisermos fazer pagamentos, trabalhar com floats, às vezes introduz algum erro, alguma falha de precisão que pode destruir os cálculos. Por isso lidamos sempre com esta unidade. Portanto, o que aqui estávamos a dizer é que 15 mil Whey é o preço que tens de se pagar para entrar na festa, na lista VIP. E, portanto, este é o resultado desta chamada aqui. Não sei se foi claro, mas é mais para dizer que diferentes métodos neste smart contract precisam de chamadas diferentes. E a maneira de nós interagirmos com um smart contract, ou seja, estes métodos todos nós podemos chamá-los, mas para chamá-los nós temos de fazer uma encriptação, uma codificação desta assinatura. Portanto, o nome do método e por exemplo, eu quero ver se certa pessoa está na lista. Como é que nós faríamos isso? Nós usamos este isAddress VIP. Eu venho ali. Ok, eu tenho um método, ele chama-se isAddress VIP. Este método tem um argumento que é um address. E o valor do address é o que é. Vamos a um address que já foi. Pode ser este address aqui. Vou copiar aqui um endereço qualquer. E este aqui provavelmente não está na lista porque eu só adicionei 2 ou 3 adereços. Por isso, o que acontece se eu fizer isto? Este é o payload que eu tenho que passar à chamada. E se eu fizer essa chamada, o que eu vou ver é... Vou ver que ele diz-me falso. Que esta pessoa não faz parte da lista. Exato, portanto, isto é um booleano convertido em ABI e é 0000. Se eu quiser um true, eu tenho que procurar uma pessoa que faz parte da lista. Por exemplo, transações anteriores que eu fiz ontem, por exemplo. Ora, portanto, estás a ver? Adicionei um membro, adicionei outro membro. Posso ver, há um dia atrás, ou seja, na rede do Ethereum tudo é público. Eu consigo ver o que é que foi feito, por quem, a que horas. Mas o que eu quero ver aqui é esta transação que aconteceu ontem. Foi chamada neste método e o payload foi este. Portanto, esta pessoa foi adicionada à lista de membros. E agora, se confirmar se ela está na lista ou não, hei de ver a partir daqui, hei de ver que realmente está. Hei de entrar. Não estou a gastar gás, porque é uma operação de leitura. Eu não estou a alterar o estado da chain. Quando altero o estado da chain, ou seja, quando eu introduzo uma transação, aí é que tenho que pagar gás. Porque os mineiros precisam ser pagos, é o custo de funcionar na rede. Pronto. Eu quero correr o programa completo. Vamos lá ver como é que eu faço isto. Pronto, o primeiro passo seria ir aqui ok, vou-vos mostrar como é que vocês correriam isto localmente, depois podem mandar mensagens e eu ajudo-vos a configurar isto, mas o primeiro passo é correr este servidor. O servidor que está aqui escrito, server.js, e o que ele está a fazer tem 3 endpoints, um é para ver se o membro está inscrito ou não, depois tem um que é só para ver se está live e o outro que é para fazer os posts. um post com um certo quê. npm run server. Portanto, o que é que o run server vai fazer? Vai lançar este servidor neste endereço e eu agora posso falar com ele. Portanto, se eu abrir, ele vai me dizer, ok, response, I'm alive. Tem aqui um servidor a correr neste 4100. E o que é que, por exemplo, o teste que fizemos há bocado com a ABI, eu posso fazer o mesmo aqui à mão. Se eu lhe passar este endereço, eu quero ver se ele está registado ou não. Vou usar aqui o Thunder. Será que eu não guardei isto? Exato, portanto, vamos fazer isto assim. Eu vou fazer um get para o endpoint do meu servidor e vou-lhe perguntar, ok, esta pessoa aqui está registada? Vai dizer falso. Ok, não está registada. Eu aqui nem estou a falar com a chain diretamente. Há bocado estava a fazer RPC para a chain. Aqui estou a falar com o meu servidor e o meu servidor fala com a chain. Isto é uma operação que não gasta gas. Ele só está a ler o estado das variáveis daquele smart contract. Se eu quiser alterar portanto, alterar e adicionar alguém à chain, então aí eu uso um post para o meu servidor. Pronto, o post seria feito assim, portanto, eu quero adicionar esta pessoa e quero dizer que a pessoa pagou 2.000 euros, por exemplo. Ou 200 euros, tanto faz. Se eu fizer isto, o servidor automaticamente vai me responder, está aqui, a pessoa foi adicionada, e se eu voltar atrás e fizer o pedido de novo, ele vai me dizer se já está adicionado ou não. Ok, ainda está falso. Tem a ver com aquilo que estávamos a falar há bocado, as transações demoram algum tempo a ser validadas. Neste momento aquilo é um pending request. Eu consigo ver isso também lá no Ethereum, no contrato. Ok, está a ver? Pending. Há 9 segundos. Isto depende do congestionamento da rede. Quanto mais transações houverem para processar, mais tempo vai demorar a ser reconhecido.
Estás na rede verdadeira do Ethereum?
Não. Estou a usar uma testnet.
Então, neste momento estás a gastar gás na testnet.
Exatamente, sim. Mas é uma testnet, por isso tens dinheiro grátis, tu podes fazer download para a tua conta. Não. Há testnets, isto é o Sepolia. Também havia o Goerli, que era com o formato antigo do Ethereum, que era por Proof of Work em vez de Proof of Stake. Mas não estou a gastar dinheiro. Ok, será que já acabou? Ok, agora foi submetido e se vocês virem ele diz aqui, ok, foi chamada a função do add member e adicionamos o endereço à lista. O endereço está ali. Se eu voltar à minha portanto, aos requests, eu consigo perguntar e ele vai me dizer sim, ok, agora a pessoa foi adicionada. Portanto, isso é o que o servidor está a fazer. Ele tem 3 endpoints. Um é para ver se a pessoa está registada, o outro é para registrar pessoas. O sítio do registro tem este formato, mandas esta mensagem com este formato para este endpoint e ele vai reconhecer. E agora, em C++, o que nós estamos a fazer é exatamente a chamar este endpoint. Se vocês virem, temos aqui este último pedaço de código. Ele está a fazer um JSON file, onde ele mete no customer o que está na descrição do payment, calcula o tier. Podemos simplificar e dizer que o tier é igual ao pagamento, ou seja, quanto mais dinheiro ele pagar, maior o tier. E depois ele também processa isso, mete no JSON e no final faz uma chamada para este endpoint com aquele JSON. Ok, por exemplo, vamos fazer aqui um teste em que eu quero registar uma... ok, teria de fazer um register. Ok, fazemos o seguinte. Como é que estamos de tempo? 30 minutos. Ok, mas, por exemplo, vamos fazer aqui uma experiência em que eu crio um pagamento off-chain para um certo endereço e depois verifico se o pagamento foi feito e no final faço o publish desse pagamento para a chain. Para fazer isso, o primeiro passo aqui é chamar a interface do Stripe. Pronto, o Stripe, o que é que eu vou fazer? Eu venho aqui ao Stripe e vou criar uma intenção de pagamento. Ou seja, isto é o que nós vamos aceder a seguir. Vou arranjar um endereço qualquer. Eu basicamente vou aqui à página inicial do Ethereum. Está aqui, pronto, este endereço pode ser. Vou adicionar esta pessoa como se ela tivesse feito um pagamento. O que é que eu vou fazer? O primeiro passo seria aqui onde diz description, dizer que portanto, ok, neste momento eu criei um invoice para esta pessoa, ou seja, esta pessoa, este endereço, pagou, este é o value, payment amount, bank ticket, ok, exato, payment, portanto, esta pessoa pagou 2.000 euros. Agora este é o ID do pagamento. Se eu agarrar o ID e passá-lo para payment confirmation, exatamente, ok, ID. O que é que vai acontecer? Ele primeiro vai tirar o rate, ou seja, quanto é que um Ethereum vale em dólares. Depois vai verificar este pagamento que eu criei agora. Ele vai ver que a pessoa correspondente, o endereço correspondente a este, e que esse endereço pagou 2.000 euros. A seguir, ele vai verificar se o pagamento é superior ao preço de admissão, e depois vai fazer o publish para a blockchain através do tal JavaScript server. Se eu fizer, se eu correr agora o programa, tenho que compilar primeiro, mas o que vai acontecer é isso. Portanto, houve um pagamento de 2.000 euros, tier 1, tier 0, tal. No meu servidor. Oi. Deu certo. DF. Aconteceu alguma coisa. Erro, mensagem de erro. Pode ter a ver com a rede. Invalid address. Invalid address. Endereço inválido. Ok, só um momento. Vou fazer aqui um teste. Estava a dizer que o endereço é inválido. Pois. Este endereço está... Não, o endereço está demasiado grande. Eu copiei um endereço que não era aquele. Pois, isto é um endereço de uma transação. Eu queria um endereço de um from. Pois, é esse o problema. Sim, é este que eu queria. Ok, já percebi o erro. O data type address corresponde há uma string com 40 caracteres que, que é validada no smart contract. Se tiveres mais de 40 caracteres, não é considerado válido e daí o erro que nós vimos. Vamos fazer curl, criar o invoice, ok. Se eu fizer isto assim, assim, assim. Ok, tenho um novo invoice, vem aqui, main. E ele criou o best invoice. Agora passo este argumento para este sítio, payment intent, e agora só tenho de correr o programa mais uma vez. Antes, correndo o programa, ele vai fazer o tal. Não digas que estava em baixo o servidor. Ok, pronto, finalmente. Então, o programa agora correu, conseguiu correr e ele está aqui a explicar que houve uma transação, esta transação foi feita e que tem a informação, ou seja, está a adicionar este endereço à lista de endereços permitidos. Ok, se eu vir, provavelmente ainda está aqui em pendente, mas eventualmente já está reconhecido. Ele fez uma chamada com esta informação. Ok. Muito bem. Acho que esta parte realmente ficou mais um bocado complicada no final. Mas, sim. Ok, muito bem. Temos mais 20 minutos, mas se calhar podemos só ver um bocado o que é que vocês têm aí, se quiserem. Ou...
Eu tenho uma que é
Então.
a linguagem de contrato. Tu aí tiveste a dizer que estava para ser complicado. Mas como é que o contrato foi lá parar? Qual é a linguagem de contrato? Aquilo que parece que acaba de ser feito aí hoje.
Não é bem. A linguagem chama-se Solidity. Este aqui, Solidity. E é bastante parecido com o C++, realmente tens aqui os imports, tens uma classe que é o contrato em si, e havia membership, depois tens member variables, tens os métodos a ser chamados, tu implementas o contrato localmente e depois fazes deploy para a rede. O deploy para a rede é uma transação também.
Pagas gás.
Pagas gás, exato.
Depende da altura que tu
Exatamente, sim. Eu consigo ver quanto é que paguei para adicionar este contrato.
E isso daí é que corre na EVM, na Ethereum Virtual Machine.
Exatamente.
É que todos os nós que estão conectados à rede do Ethereum ocorrem essas coisas.
Exatamente, sim. Quando fazes envias um evento que conecta com este contrato, consegues ver. Exato, a Virtual Machine vai. Contract Creator. Ok, está aqui. Mais informação. Transaction Fee. Pronto, este foi o valor pago para adicionar. Aliás, gas price está aqui. O valor que eu paguei para adicionar este contrato. Mas isto é negligenciável, é tipo mínimo. Numa transação de milhões de Ether, tu pagas menos do que cêntimos. Não é. Até dizer. Yeah. Sim. E também a troca de Proof of Work para Proof of Stake. Exatamente, yeah. Consegues processar mais transações, elas são mais baratas e tudo. Ok. Prontos. que vamos, não sei se querem fechar isto com mais alguma questão, mas em princípio acho que era isto que vos queria mostrar. E vocês têm acesso ao repositório, podem puxá-lo, utilizá-lo. Se tiverem dúvidas, mandam um e-mail. Posso ajudar a processar isto. A tua questão de como é que isto foi deployed. O deployment de um contrato, tu consegues fazer, há plataformas que simplificam isso, tu metes as tuas credenciais e vais pagar algum dinheiro para fazer o post, por isso tens de ter uma conta com dinheiro. Eu estou a usar a testnet, por isso há uma faucet que te dá dinheiro para tu usares nesta testnet. As credenciais eu tive de adicioná-las, mas onde é que está o código? Deployment. Deploy. Se quiseres fazer isso, consegues fazer deploy do teu do contrato por ti. Ok. Portanto, o código em si é isto. Aqui defines o nome do teu contrato na network e para chamares este ficheiro tu fazes com este run hardhat deployment js network support. Tipo, behind the scenes, ele vai-te compilar este Solidity contract para garantir que isto é um contrato válido e depois vai fazer o deploy e aparece aqui no terminal foi deployed para este endereço, se quiseres.
Mas é compilado ou é incompilado?
Compilado.
É compilado.
Não tenho certeza agora dos detalhes, mas eu diria que é compilado. Se tu cometes um erro de data type, falha automaticamente, porque um contrato é suposto ser imutável. A partir do momento em que ele entra na rede, não vais voltar a mudá-lo, por isso só tens uma tentativa. Ele garante que o contrato é válido e que está bem escrito. Okay, then I think that's all, folks.